Good morning. The video today is on square roots. It is covering lesson 3.8 on page 176. Probably are going to want to be in your textbook. I'm going to have to use the Word document today because it did not transfer to the Smart Notebook software very well. So we'll just have to be patient. Square roots. It's that funny looking symbol that looks like a division sign, but isn't really. It is, but it's a special division sign. So we'll talk about that today. Square root defined. What is a square root? Square root uses the radical symbol. That symbol is known as a radical. The square root is a number the product of a number multiplied by itself. It's the number. So let's look at this example. When a squared, what is a squared when a equals 3? Well, a squared means a times a, or 3 times 3, which is 9. The inverse of squaring a number is the square root. So if 3 squared, which is 3 times 3, equals 9, then the square root of 9 will equal 3. So squaring a number, to undo squaring a number, you will get the square root of the number. However, is 3 times 3 the only way that I can have a product of 9? Is there any other number that I can multiply by itself? I know there's 9 times 1, or 1 times 9, but is there any other number that I could multiply by itself, like 3 times 3, to get 9? What about -3 times -3? A negative times a negative is a positive, and 3 times 3 is 9. So essentially, when we're talking about the square root of 9, do we have two answers? Positive and -3? We'll talk about that as we go on. As you notice in my chart, that is true. Every square root, so when I look at the square root of 9, positive and -3 could be a result. Moving on. Let's look at example 1. Example 1, we're simplifying square roots. So we're finding the square root of 49. What number times itself equals 49? You should be saying 7. Now, you might also say -7, and that is true. However, I want you to look at this problem and this one. When there is not a sign in front, typically we're just looking for the positive result. Here, I want to know the opposite of the square root of 49, or the negative square root, not 49, the negative square root of 121. Well, what number times itself will equal 121? You should be saying 11. And since it was negative, we're going to say -11. Notice here, I have a positive negative. So in other words, I'm looking for both numbers times itself that equal 36. And that would be positive and -6. The This is how you can show positive and negative, that you're looking at both. Last one in example 1. Following that example, the square root of 1/25. Ooh, we have a fraction. When we're finding the square root of a fraction, we're finding the square root of the numerator and the square root of the denominator. So what number times itself will equal 1? 1. And what number times itself will equal 25? 5. So the square root of 1/25 is 1/5. Okay? We're going to get into what these numbers were. They're called special numbers. But before we do that, we're going to move on to example 2. Example 2 is at the top of page 177. And it's going to tell us that every square root will either be a rational or an irrational number. Do you remember when we studied rational numbers earlier in the school year? Rational numbers, they can exist of whole numbers, integers, real numbers, like fractions, and decimals. When we're talking about decimals, we're talking about terminating and repeating. We're talking about irrational numbers. We're talking about decimals that do not repeat and do not terminate. Okay? On your calculator, you are going to have a symbol that looks like this. When we do use our calculator, depending on what type of calculator you have, you're either going to hit the radical symbol first and then the number, or you will type in the number, then the radical. Let's just practice. Let's practice on a few of these. The square root of 8. Okay, turn on your calculator. 8, and square root it. What did you get? You got a long decimal. 2.828427. Sometimes when we have numbers that will not come out as a decimal, we'll ask you to round. Here, I'm not going to ask you to round, though. I'm going to ask you, do you think 2.828427, and mine continues to go 125, do you think that's a rational number or an irrational number? I would say irrational number. Okay, let's try the next one. The opposite, or the negative square root of 75. We don't need to put in negative. We just need to find out the square root of 75. And here I got 8.660254 and a few more numbers. Do you think that is rational or irrational? Again, irrational. Positive, negative square roots of 225. So it's going to be a positive. Let's take the square root of 225, and we get 15. Rational or irrational? It is a rational number. I don't think we need our calculator for the next one. The square root of 1/4. We know the square root of 1 is 1. The square root of 4. Is there a number times itself that will equal 4? Yes, 2. 1/2 is a rational number. Just determining if it's rational or irrational. Let's move on to a couple more here. Let's talk about perfect squares for a minute. It's at the middle of page 177. Perfect squares. If you look at their listing consecutive integers, 1, 2, 3, 4, 5, 6, 7. The perfect squares are the squares of these numbers. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5, 25, 6, 36, 7, 49. These numbers are your perfect squares. Why are they perfect squares? Because there is a special number that is multiplied by itself to get that number. If I give you the number 81, is it a perfect square? Yes, because 9 times 9 is 81. It would be beneficial for you to memorize the first 20 perfect squares. Hopefully you already know the first 12, maybe even 13. All right, let's look at example 3. We're estimating estimating square roots. The square root of 39, not 36, 39. The number 39, I keep writing 36. The number 39 falls between what two perfect squares? You look at my list, it falls between 36 and 49, right? That means the square root of 39 is going to come between the numbers 6 and 7. So the square root of 39 is between 6 and 7. Or we could say this: 6 is less than the square root of 39, but the square root of 39 is less than 7. Okay. How about the square root of 105? Can you think of a perfect square close to 105? 100. What is the square root of 100? 10, because 10 times 10 is 100. So if that is below 105, then I need to go to 11 times 11, which is 121. So the square root of 105 is between 10 and 11. All right, 2 more quick ones. Approximations. Let's approximate the square root of 86 to the nearest hundredth. Okay, get your calculator out again. Let me clear this off before the computer decides to insert it as Word. The square root of 86 to the nearest hundredth. Okay, let's type in our calculator, the square root of 86. Notice I said to the nearest hundredth. That's how many decimal places? 2 places. So the square root of 86 is 9.2736. Hundredth is 7. So the square root of 86 to the nearest hundredth. Remember, no sign, so I'm probably just looking for the positive. 9.27. We here, positive, negative, square root of 5. Okay, let's find the square root of 5. And it is 2.236. Nearest hundredth, that's the 3. Should it stay at 3 or round to a 4? Should go to a 4. So it's the positive, negative 2.24. Many formulas will use the square root and squaring. So let's look at our last example together. We're going to use this formula, the square root of x squared plus 2x squared. The square root of all of that. My computer wouldn't do that, but it should really look like this. It's on page 178 in your textbook. Okay? When you have formulas like this, all we're going to do is use substitution. X is representing the height of the tower. So if we have a tower that's 140 feet tall, and D is going to tell us how long the supporting wire needs to be, let's just rewrite the formula. D equals the square root. Instead of X, I'm going to write 140. So 140 squared plus 2 times 140 squared. Okay? Do the math of that. So 140 squared is 19,600 plus 2 times 140, which is 280. And I'm going to square that. So I have 19,600 plus 78,400. I get 98,000. I need to find the square root of 98,000. Something's not working out right. To the nearest tenth of a foot, I have 313 feet. Okay, if you have any questions over square roots, let us know. Otherwise, your assignment will be given to you tomorrow in class.